Preparing for what comes next is a big part of becoming an adult. So, if your teenager says they want to join the military, they're preparing for a real challenge. Visit todaysmilitary.com because their success tomorrow begins with your support today.
We can stop HIV, Iowa. Unfortunately, there are barriers that make our job a little more difficult.
Stigma is one of our biggest challenges.
So we should talk about HIV more.
And support people living with HIV.
Visit stophiviowa.org.
This is SpaceTime, Series 23, Episode 23, for broadcast on the 20th of March, 2020. Coming up on SpaceTime, a new contender for mysterious dark matter, a rare merger of two white dwarf stars, and scientists have successfully extended the life of a satellite in orbit, a sort of in-orbit refuelling and servicing. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have identified a subatomic particle which could be a new contender for dark matter. Dark matter is one of the biggest questions facing science today. Up to 80% of the universe is composed of dark matter, but scientists have no idea what it is. Despite many decades of research, this invisible substance remains a complete mystery. Scientists know dark matter exists because they can see its gravitational interaction with normal matter, such as preventing galaxies from flinging apart as they rotate. Science's best current hypotheses consider dark matter to be made up of a yet unidentified subatomic particle, possibly involving some sort of new physics. And there are many candidates, from hypothetical axions to new kinds of yet-to-be-discovered neutrinos. And now a new candidate called a D-star hexaquark can be added to the mix. Hexaquarks are composed of 6 quarks, the fundamental particles that usually combine in groups of 3s to make up the protons and neutrons of baryonic matter, the stuff that stars, planets, houses, cars, dogs, cats and people are made of. Importantly, the 6 quarks in the D-star hexaquark results in a boson particle, which means that when a number of hexaquarks are present, they can combine together in very different ways to protons and neutrons. Boson particles have integer spin. In 2014, scientists with the Cooler synchrotron COSY accelerator confirmed the 2011 detection of an exotic dibaryon made up of 6 quarks, in other words, the D-star hexaquark. It was discovered at an energy level of 2,380 millielectron volts, lasting for about 10 to the minus 23 seconds. Although they're composed of 6 rather than the usual 3 quarks, hexaquarks are actually much smaller and they're far less stable and so decay quickly. Now, a report in the journal Physics G Letters suggests that in the extreme conditions of the quark-gluon plasma that existed in the primordial universe shortly after the Big Bang 13.82 billion years ago, D-star hexaquarks could have grouped together, forming a 5th state of matter known as a Bose-Einstein condensate. These days, Bose-Einstein condensates are created when groups of atoms or molecules are cooled to almost absolute zero, minus 273 degrees Celsius. At these extreme temperatures, they become locked together in the lowest quantum state, causing them to begin to act as if they were a single giant particle or atom. One of the study's authors, Professor Daniel Watts from the University of York, says that according to his team's calculations, Bose-Einstein condensates comprised of hexaquarks would be feasible as a new dark matter candidate. Importantly, if correct, it would all fit in with the standard model of particle physics and wouldn't require any new types of exotic physics to work. The study's co-author, Dr. Mikhail Brashnikov, also from the University of York, says the next step will be trying to get a better understanding of how hexaquarks interact with each other, when do they attract each other, and when do they repel. This is SpaceTime. Coming up next, astronomers identify an unusually massive white dwarf star, which they think could be the result of a rare merger between 2 smaller white dwarfs. And later in the Science Report, we look at some of the fake news about the COVID-19 Chinese coronavirus. All that and much more still to come on SpaceTime. Okay, let's take a break from our show to talk about our sponsor, The Great Courses Plus. As you know, SpaceTime covers the entire spectrum of space and astronomy news. And one topic I like to keep tabs on is the discovery of new Earth-like exoplanets. For instance, according to new data, an exoplanet called K218b, which is more than twice the size of Earth, may well have the right conditions to host life. But how do scientists reach that conclusion? What do they base that on? I mean, it's not like they can fly there and have a look for themselves. Veteran planet hunter Joshua Wynne has the answers in his new course on the Great Courses Plus called The Search for Exoplanets: What Astronomers Know. In this course, you'll learn about the technological advances behind the acceleration in discoveries. After all, it wasn't that long ago when we found our first exoplanet, Pegasi 51. Now we've confirmed more than 4,000. This course lets you study the conditions that make Earth habitable, its distance from the Sun, its surface temperature, its oceans, and the extraordinary science being used by astronomers around the planet to hunt down exoplanets. If you have an interest in extrasolar planetary discoveries and the search for extraterrestrial life, you'll love this course, The Search for Exoplanets: What Astronomers Know. And this course, together with thousands of other lectures, can be found at the Great Courses Plus. It's a streaming service with reliable, fact-based information, and it's all presented by the top professors and experts in their field. And it's not just astronomy. The Great Courses Plus have lectures covering a wide variety of subjects, so there's something there for everyone. I'm pretty sure that once you try it, you'll love the Great Courses Plus. And right now they're offering SpaceTime listeners a free trial with unlimited access to their entire library. All you need to do is sign up through our special URL to take advantage of this great offer. You can start your free trial today. Just go to thegreatcoursesplus.com/space. That's thegreatcoursesplus.com/space to take up your free trial offer. And of course, you'll find the URL and the show notes on our website. That's thegreatcoursesplus.com/space. And now, it's back to our show.
This is SpaceTime with Stuart Gary.
Astronomers have identified an unusually massive white dwarf star, which they believe could be the result of a rare merger between two smaller white dwarfs. The discovery could raise new questions about the evolution of massive white dwarf stars and on the number of supernovae in our galaxy. White dwarfs are the stellar corpses of dead sun-like stars, which have ceased the nuclear fusion process in their core, which makes stars shine. You see, after running out of core hydrogen for nuclear fusion into helium, these stars begin fusing helium into carbon and oxygen. However, once the helium runs out, these stars aren't massive enough to fuse the carbon and oxygen into heavier elements, and so the nuclear fusion process stops. Once fusion is stopped, these dying stars lose their outer gaseous envelopes, which float away as planetary nebula. What's left is a white-hot stellar core, called a white dwarf, which is left to slowly cool over the eons of time. This newly discovered massive white dwarf, reported in the journal Nature Astronomy, was detected relatively nearby in galactic terms, just 150 light-years away. Catalogued as WDJ0551 plus 4135, it was spotted in data gathered by the European Space Agency's Gaia Space Telescope. Astronomers noticed that it had an unusually high mass. So the authors followed up with spectroscopy taken by the William Herschel Space Telescope to identify the chemical composition of its atmosphere. They found that it has an unusually high level of carbon, and that's thought to be caused by the merger of two smaller white dwarfs. If correct, it's the first time that a merged white dwarf has been identified using its atmospheric composition as a clue. The study's lead author, Dr. Mark Hollands from the University of Warwick, says the star stood out as something never seen before. Usually when it comes to white dwarfs, astronomers expect to see an outer layer of hydrogen, sometimes mixed with helium or just a mix of helium and carbon. But no one expected to see this combination of hydrogen and carbon at the same time, as there should have been a thick layer of helium in between, prohibiting that. So to solve the puzzle, the astronomers turned detective to uncover the star's true origins. White dwarfs are relatively lightweight stellar remnants, often just over half the mass of the Sun. But this one had approximately 1.14 solar masses, nearly twice the average. Despite being heavier than the Sun, all this mass is compacted down into a superdense object just 2/3 the diameter of the Earth. The age of the white dwarf is also a clue. Older stars orbit the Milky Way faster than younger ones, and this object's moving faster than 99% of other nearby white dwarfs with the same cooling age, and that suggests the star is older than it looks. The result is a combination that can't be explained through normal stellar evolution. Firstly, you've got a mass twice the average for a white dwarf, and then there's a kinematic age which is clearly older than that inferred from cooling. Holland says astronomers are fairly certain how a star turns into a white dwarf, and this one shouldn't be doing what it does. He says the only way to explain the observations is that it formed through the merger of two smaller white dwarfs. The idea is that one star in a binary system expands at the end of its life and envelops its partner, drawing its orbit closer as the first star shrinks. The same will happen when the other star expands. Then, over billions of years, gravitational wave emissions will shrink the orbit further, to the point where the two stars eventually merge. Now, while white dwarf mergers have been predicted to occur before, this one would be especially unusual. You see, most of the mergers in our galaxies are between stars with different masses, but this merger appears to be between two stars of similar mass. Now, further complicating all this is the Chandrasekhar limit, which limits the mass of a white dwarf to 1.44 solar masses. Anything larger would violate the Pauli exclusion principle, which gives rise to a phenomenon of quantum mechanics known as electron degeneracy pressure. Put simply, two or more electrons, being fermions, can't occupy the same state or minimum energy level at the same time. However, the gravitational forces crushing down on an object more than 1.44 solar masses would be so great it forces the negatively charged electron into the positively charged proton of the nucleus, creating a neutron. And this would cause the white dwarf to explode in a thermonuclear supernova. Because the white dwarf hasn't gone supernova, this discovery is useful for demonstrating how massive a white dwarf can get and still survive. Holland says the most exciting aspect of the star is that it must only just have failed to explode as a Type 1a supernova. And that's important because these gargantuan explosions are used to map the structure of the universe because they can be detected out to very large distances. However, there remains much uncertainty about what kind of stellar systems make it to the supernova stage. Strange as it may sound, measuring the properties of this failed supernova and similar white dwarfs in the future is telling scientists a lot about the pathways to thermonuclear self-annihilation. Because the merging process restarts the cooling of the star, it's difficult to determine how old this white dwarf is. The authors think the two white dwarfs probably merged into the single bigger white dwarf around 1.3 billion years ago. But the two white dwarfs may have existed for many billions of years before that. It's only one of a handful of merged white dwarfs to be identified so far, and the only one detected by its composition. Holland says there aren't many white dwarfs this massive, although there are more than you'd expect to see, which implies that at least some of them were probably formed through mergers. He's now hoping to use a technique called astroseismology to learn more about the white dwarf's core composition from its stellar pulsations, which would be an independent method of confirming that this star did indeed form from a merger. You're listening to SpaceTime. Still to come, a new in-orbit satellite salvage spacecraft begins operations, and later in the science report, a new study confirms that man-made climate change made Australia's devastating summer bushfires 30% more likely to occur. All that and more still to come on SpaceTime. Northrop Grumman has undertaken their first orbital satellite refuelling operation, successfully linking up with an aging telecommunications satellite in geostationary orbit 36,000 kilometres above the equator. The operation involved the company's mission extension vehicle MEV-1 rendezvousing with and then clamping onto a 19-year-old Intelsat 901 satellite, providing the fuel to keep it operational for another 5 years. Operated by Northrop Grumman subsidiary Space Logistics, MEV-1 was launched from Kazakhstan in October. Intelsat 901 was never designed to undergo an in-orbit docking, so the intercept was carried out at a slightly higher than normal orbit in order to avoid damaging other satellites if something went drastically wrong. The telecommunications satellite only had a few months of fuel remaining on board after ending its expected service life late last year. So it then used this fuel to position itself into a higher orbit for docking with MEV-1. Once back down into its operational orbit, Intelsat 901 will resume operations in about a month or so. And once its 5-year support mission is over, MEV-1 will detach and move to another satellite where it will repeat the operation. Northrop Grumman envisages a growing satellite refuelling and robotic repairs operation over the coming decade, and it plans to launch a second rescue satellite later this year. For most sky watchers, finding the right beginner's telescope can be a daunting task. It's not just the technical terminology, but also the sorts of features you want, what you want to use the telescope for, and even where you'll be using it. Now, for most people listening to this program, you'll be using your telescope for astronomical observations rather than terrestrial viewing. If you're really into checking out the neighbours or you're a part-time pirate, then an astronomical telescope won't work for you. The most important feature of any astronomical telescope is its aperture, that is, the diameter of the telescope's main optical component, either a lens or a mirror. The aperture determines how much light the telescope can capture, and the more light, the more objects you'll see, and the sharper and clearer they'll appear. But remember, the bigger the aperture, the bigger the telescope, which is cool if you plan on leaving it in your backyard or on the balcony, but it can be a real pain if you plan on taking it out to dark sky areas away from city lights. Now, you've probably also been thinking about magnification power. But the thing is, that's really not what it's about. That's not that important. That's because you can change your magnification as easily as changing the telescope's eyepiece. And remember, too much magnification simply results in highlighting air particles in the atmosphere rather than the astronomical objects you're looking for. So, what type of telescope should you buy? A reflector, a refractor, or a Cassegrain? Refracting telescopes are the most common. Think of the ones pirates used. Refractors use lenses instead of mirrors with the eyepiece at one end. They're easy to use thanks to their simple design, they need virtually no maintenance, and they're great for looking at the moon and planets. But they have smaller apertures and so aren't very good for looking at deep space objects, such as other galaxies, nebulae, or star clusters. Then there's reflecting telescopes. They use a mirror instead of lenses, and the eyepiece is located on the side of the main tube. They usually have larger apertures, meaning you get bright images of deep sky objects. The main disadvantage is the extra cleaning needed to keep them dust-free. Then there's Cassegrain telescopes, which are a combination of mirrors and lenses. They're the most versatile, with excellent lunar, planetary and deep space observing. And they're great for astrophotography with fast films or CCDs. But they're also much more expensive than reflectors with the same aperture. Now, you'll also need a really stable mount for your telescope. The basic azimuth mounts are simple designs, letting you go up or down, left or right, that's about it. And you also need to move your telescope manually to follow objects across the sky as the Earth turns. On the other hand, equatorial mounts cost more, but they're worth it as they let you follow the rotation of the sky as the Earth revolves. And that's really great when you're trying to find your way around the heavens or taking long exposure images. Working out what telescope to buy is one of the features in the current issue of Australian Sky and Telescope magazine. Joining us now with the details is the magazine's editor, Jonathan Nally.
Hobby killers. These are the sort of cheap telescopes you can get at department stores and odd shops here and there, and other places that don't specialise in telescopes, right? So there must be thousands and thousands of cheap telescopes with cheap mounts and rubbish eyepieces out there just gathering dust in cupboards. You know, they've been bought as birthday presents or Christmas gifts, and the kid excitedly unpacks it, then no one knows how to use it, no one knows how to put it together, and if they do get it together, they realise it's cheap rubbish, and it just gets shoved in a box somewhere, and it's a real sad thing. It's just a complete waste of money, unfortunately. And a bad telescope is something that actually can turn people away from astronomy. You know, they get all excited about it, and then, this is not much fun after all. So it's really worth learning a little bit about it to avoid that sort of disappointment. So we've got a really good article in the February-March issue of Australian Sky and Telescope about how to buy your first telescope. So we show you how to work out which is the sort of telescope that's best for you or for someone else if you're giving it as a gift. And that you don't have to spend a fortune. All you really need to do is know what to look for so that you can assess the optics inside the telescope, which is pretty easy to do. Test the mount of the tripod to make sure it's not wobbly, because that's a really bad thing. Because if you're looking through your telescope in the dark of night and you accidentally bump it, which everyone does, if it starts wobbling and then it keeps wobbling. Now, 30 seconds later, that's not really enjoyable to look through. So a telescope mount should be solid, shouldn't wobble. So if you do accidentally bump it, it should settle down back to a nice stiff state within a second or half a second or so. So we tell you how to look out for that. And, also all this before you fork out your hard-earned cash. So telescopes are always a popular gift idea, and even if it's a gift for yourself, you've always wanted a telescope. It makes sense to sort of get a bit of knowledge before you go looking so that you know what you're looking for.
I live in the heart of the biggest city in Australia. Do I need a telescope? Is it any good for me? I mean, you can barely see the stars where I live.
Well, this is the problem when you've got light pollution, that it's going to drown out a lot of the faint things that you would see from a dark location, so galaxies and whatnot. But for the beginner, for the sort of things that you would start off with, which is the moon, perfectly bright enough, the planets, fine, star clusters, all the sort of bright stuff you can see with a small, inexpensive telescope, and that'll just get you going. So that's the way to do it. And, it used to be said that, because telescopes used to be fairly expensive, even small beginners ones, but because they're more mass-produced now, they've come down a lot in price. But when they were more expensive, the advice used to be, don't spend $500 on a cheap telescope. Buy yourself a good pair of binoculars instead, because a good size pair of binoculars is just as good as a small telescope. You can use both eyes so you get better vision, and you can use your binoculars during the day for other things, and that's what we used to say. These days, you don't have to spend $500 getting a good beginner telescope. You can get one for less than $200. So, if you're a city dweller, I would certainly go for it. And then as you get more and more experienced and you want to continue with it, you can then start getting into things like special filters that you put on that will cut out the glow from your nearby streetlights and other things, and that does really improve the appearance of deep sky objects. And of course, once if you get into it, you like your small telescope and you want to continue in astronomy, you will get what's called aperture fever. Aperture meaning the size of the telescope, the width of it. Aperture fever means you just keep on getting a bigger and bigger telescope.
And then you have your backyard observatory, and the next thing you know, you've bought a block of land outside Los Angeles, and you have a second telescope set up there, so you have one operating in remote control from the other, and then you're hooked.
You can do that, and that used to be what people did, and people still do, although these days, of course, there are plenty of what's called telescope farms around the world that people have set up where you don't have to go to the expense of buying your own block of land out in the middle of nowhere and building an observatory. You just rent time on these over the internet, and they've got some super duper ginormous and fantastic, super sophisticated telescopes, and you can rent them by the hour, and you can tell it what you want it to take photographs of because they've all got cameras attached. It's a really good way to do it. But of course, you need to know a bit about astronomy first. You need to know a way around the sky. You need to know what you want to look at. So getting a beginner's telescope and starting to learn is a great way to do it.
That's Jonathan Nally from Australian Sky and Telescope magazine. And this is SpaceTime. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. A paper published last year which claimed that global warming was caused by the sun's been retracted after it was discovered that the research was based on a flawed assumption. The move to retract follows strong criticism from scientists, prompting a review of the work. The study had wrongly claimed that global warming was being caused by changes in the distance between the Sun and the Earth, due in part to the movement of the Sun due to the gravitational influence of the planets orbiting it. In other words, it's the same wobble method planetary scientists use to detect exoplanets orbiting distant stars. However, it was pointed out that even the largest of these movements in our solar system, caused by Jupiter orbiting the Sun, would only make the Sun wobble by about a metre or so, and the combined effect of all the other planets would be even less. The authors of the study had wrongly claimed that the wobble would be as much as 3 million kilometres over a few hundred years. Now, the Earth's orbit also changes as it circles the Sun due to gravitational perturbations from the other planets, the degree of its orbital elongation and eccentricity, and the precession of both its elliptical orbit and its axis. But these regular changes, known as Milankovitch cycles, occur over timescales of tens of thousands of years. That's far beyond the 200 or so years since the Industrial Revolution and its associated sudden increase in the use of fossil fuels, which are the real cause of climate change. The reviewers concluded the current rate of global warming simply cannot be explained by such a gradual change in orbit. And it's not the first time the same author has come under scrutiny over their research regarding climate change. Back in 2015, this author was criticised by the scientists after suggesting that an expected quiet period of solar activity would cause a mini ice age to occur, which would offset the current rate of global warming. That work was also found to be inaccurate. A new study, which has been peer-reviewed, says human-caused climate change made southeastern Australia's devastating bushfires over the last few months at least 30% more likely to occur. They say the prolonged heat wave which baked the country over summer was the primary factor raising the fire risk. The study by scientists at the University of Oxford, the Royal Netherlands Meteorological Institute and the World Weather Attribution Project also linked the extremity of the heat wave to climate change, with scientists saying that such an intense heat wave in the region is about 10 times more likely now compared to what it would have been likely in the year 1900. The bushfires burnt through an estimated 18 million hectares, costing the life of 34 people, destroying 6,000 buildings, and killing well over 1.5 billion animals, including many endangered species. The study's climate simulations showed that the probability of a high fire weather index during the 2019-2020 season increased by at least 30% relative to the fire risk in 2010, primarily due to the increased extreme heat. 2019 was Australia's hottest and driest year since modern record-keeping began. A new study claims regular use of fish oil supplements may be linked to a lower risk of death and cardiovascular disease, including heart attack and stroke. The findings, reported in the British Medical Journal, are based on a study of 430,000 people aged between 40 and 69 in the UK. Almost a third of the participants reported taking regular fish oil supplements at the start of the study, and they were found to be 13% less likely to die from any cause. They were also 16% less likely to die from heart issues and 7% less likely to have a heart attack or stroke compared to people who didn't pop the supplements. However, the authors point out that this type of study can't actually show that fish oil supplements cause the reduction in the risk seen. A small study out of Murdoch University has shown that saffron can enhance the quality of sleep in adults who have been failing to get enough shut-eye. Saffron's a popular but expensive spice derived from the flower known as the saffron crocus. Previous studies have suggested saffron could help reduce symptoms for people who have mild or even moderate depression. The new research, which was funded by the manufacturer of a saffron extract product, used 55 volunteers who had not been treated for depression, who were physically healthy, and who had been medication-free for at least 4 weeks and had self-reported symptoms of poor sleep. However, while the study, which has been reported in the Journal of Clinical Sleep Medicine, did find that saffron improved sleep quality in the first week of administering the supplement, the authors had used a pharmaceutical-grade of saffron extract called Afron, dosed at 40 milligrams twice per day as part of the research, which means that people would struggle to get the same sort of benefits by simply taking raw dried saffron or over-the-counter supplements. A new study claims men can distinguish between the sense of sexually aroused and non-aroused women. The research by scientists at the University of Kent and reported in the Archives of Sexual Behaviour claimed the detection of sexual arousal through smell may function as an additional channel in the communication of sexual interest and provide further verification of human sexual interest. The research expands on previous studies suggesting humans can communicate and detect emotions such as fear or sadness through scent. Sexual arousal is also identified as an emotional physical state. The study involved men inhaling scents from sweat samples taken from both anonymous aroused and non-aroused women. The study found that men found the scent of aroused women as relatively more attractive. The findings suggest that the chemical signals in the scent alone can elicit a sexual response in recipients. Well, you may have noticed it's now impossible to watch a news bulletin that doesn't mention the worsening COVID-19 Chinese coronavirus. Well over 100,000 people have now been infected and more than 5,000 fatalities have been reported. Although the disease began in the horrific live meat markets of China's Wuhan province, it's now spread through human-to-human contact around the globe. The World Health Organization has now listed COVID-19 as a pandemic with a mortality rate of 3.4%, with older people and those with compromised immune systems far more likely to die than the general population. The global effects have been devastating, with countries in lockdown, travel restrictions stiffened, schools have been closed, stock markets have suffered major falls, even concerts and sporting events, including the Australian Grand Prix, have been cancelled as the epidemic continues to spread. But so much of the news on COVID-19, especially what's appearing on social media, is fake, as Tim Mendham from Australian Skeptics explains.
Started with saying this was information from the Bureau of Diseaseology, Parramatta. Now, there's no such thing as
Diseaseology and Paramatter.
the Bureau of Disease. Apart from the fact there's no word diseaseology, and there's certainly no Bureau of
Diseaseology.
No. So, I mean, and it's this warning, which is spread everywhere, as things do on social media, full of typos and appallingly things. It says the things you should not eat, including fortune cookies, mee goreng noodles, Yakult, which doesn't come from China, Wagyu beef, which doesn't come from China. It actually comes from Australia, I think, half of it. So, I mean, all these things you shouldn't eat. It's pure racism, in other words.
So people are using this as a tool to spread their racist views.
Absolutely. I mean, that's one avenue for them. This is a Chinese-based disease, and it is Chinese-based disease. We know that. But, I mean, and therefore suddenly everything Chinese becomes tainted with this thing. Not to mention the conspiracy theories that have shot up that it was actually a disease. All sorts of things. Someone suggested that it was actually a disease created to take the focus off the Hong Kong riots. All sorts of things. But it goes on.
Well, the riots
There's
have
all
stopped
sorts of,
in Hong Kong, so...
Yeah, I think because no one wants to go out in the open. But, I mean, yeah, all sorts of things that are being put forward, alternative cures and things. There's a story about bat soup, this sort of Chinese singer eating bats, and that how it was created the coronavirus outbreak. The fact that the photo being used was 3 years old. It was in the island of Palau. It was nothing to do with this, and so not at the same time. It's beside the point. But that's social media for you. Being used as a biological weapon, all sorts of things like that have kept cropping up. The interesting thing is that one of the Chinese news agency, the official Chinese news agency, Xinhua, I hope I pronounced that correctly, put out a notice, which is strange for them, saying that people should try a herbal medicine, and this I have trouble pronouncing, Shuanghong Liang, I think it's called. And it's a herbal cure. This is a traditional Chinese medicine, which, as we know, traditional Chinese medicine is very much a hit-and-miss affair. But one of the most interesting things...
traditional Chinese medicine was invented by Chairman Mao in the 1940s, wasn't it?
He certainly promoted it because Western medicine was so much more advanced.
And so much better, but also expensive. And
expensive, and they couldn't afford it. So therefore, traditional Chinese medicine is homegrown medicine, and therefore let's go for that and say it works, which it doesn't. That's now a huge industry, multi-billions and billions and billions of dollars, especially in China. Also the fact that it uses and abuses amazing amounts of wildlife, rare wildlife becoming extinct. But one of the components of this Shuanghong Liang is a product called forsythia. In fact, it's a mixture of honeysuckle, Chinese skullcat, which I think is a mushroom, is it, and forsythia. And forsythia was a product being promoted by a homeopath in the film Contagion. And the film Contagion is probably one of the best films about how science works, especially in the medical arena. If you haven't seen the film Contagion with Kate Winslet and various others, go see it or get it on DVD or whatever. It is a great film about the way science works. It drags in people, including Barry Marshall from WA, who got the Nobel Prize for his work on ulcers. But this forsythia is a product being promoted by a homeopath conspiracy theory podcaster. And here it appears again in this report from Xinhua about what to do to cure coronavirus. So it is an interesting contrast there between myth and a movie that actually comes very close to being reality, increasingly so considering what's happening right now.
The evidence, according to the genetic testing, is that it did originally come from bats, but the vector, it's rather ironic. Originally they said the vector was snakes, but they've now decided the more likely vector is pangolins, which just happen to be an endangered species, which is being used in Chinese medicine.
Exactly right, and being sort of really threatened with sort of extinction because of the huge amounts of pangolin scales that are being used for traditional Chinese medicine.
And
it's just horrifying.
You can get the same thing by chewing your fingernails.
Yeah, I know.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free twice-weekly podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
See care in a new light at Madonna Rehabilitation Hospitals, where top medical minds lift you up, where the very best in specialized rehabilitation brings out your very best, where over 60 years of breakthroughs in research and technology spark your newfound strength. In our world-class hospitals, this is something greater than rehabilitation. It's renewed strength for life. Learn more at madonnarehab.org.